Hello, my name is Tim Lethbridge. I've been asked to explain a little bit about how the catenary system works on the OC-Transpo O train. It's been damaged, and a lot of people are saying, could you explain a little bit about how it works? First of all, let's take a look at an overview of the catenary system. Okay, so here you see two poles. Okay, and between the poles, there is a wire that droops, because wires will droop between two poles. And then there are these things called droppers that hang off the drooping wire. And then there is a wire that is supposed to stay pretty much level with the track. The track's sloping, it'll be sloping too, but it's basically the same height above the track that actually the electricity transmits to the train, to the pantograph on the train. Okay, so that's the way the system works in Ottawa. There are other systems that are more sophisticated or less sophisticated, but this is basically what's happening here in Ottawa. All of this is powered, so the power is in the messenger wire and also in the lower wire, which transmits to the pantograph. We will see that there are also connections that connect them electrically, as well as the droppers. Here's another schematic. Now, this is not the Ottawa system, but it shows a little bit more. I got this from the web. It shows a little bit more about how some of these things work. Okay, so we have poles, and we'll see some real Ottawa poles in a moment. And then we have this support structure. Okay, so this is the support structure. Support structure has a couple of arms to hold up the system. And then there's this thing called the registration arm, okay, that runs, if I can find my cursor again, that runs along here. And then this steady arm that actually holds the wire itself, okay? We're going to see that the steady arm is facing the other direction in the Ottawa setup. But the two wires of the catenary are hung off this, and this whole setup is designed to make sure that the wires are at exactly the right height. Okay, so let's take a look now at an actual normal standard Ottawa setup. So we have the pole in the center, okay, and we have two tracks. Now this is taken just outside the site building at the University of Ottawa. Okay, so we have the eastbound track on the left. I'm actually facing towards downtown right now. In a few minutes, I'm going to turn around and face the other way. So the eastbound is where the damage is, further down, not at this point. This is a normal setup. This is the westbound line. So you can see here, you have at the top, you have your hanging line that's got the power in it. And hanging off that, you can just see these droppers here, okay? The droppers, here's a piece of a dropper here that hold this conduction line steady so that the train can scrape gently along it with its pantograph, okay? So westbound line, eastbound line, okay? And 90% of all of the poles in the Ottawa system look like this, okay? But let's go one step further on. Okay, so this is the next pole. Now we've changed, and now we are actually facing towards the east. I basically just swivel the camera around, take a few steps downhill towards Lee Station. Okay, so what you see here is you can still see the westbound line, which is now on your left, and you can see the droppers off that. And you can also see the eastbound, which is on the far line, which is on the far right of your screen. So you've got your main line and your conduction line there. But you also see something more interesting. You see a line coming out of the center from the actual tower itself. And what that is the beginning of a new cable that is going to stretch from this point along the eastbound track way out past Lees towards Herdman. And ultimately, it's this structure that has failed further on. We'll see that in a few minutes. If you look, you can also see some weights hanging off this. These weights are on the ground because the tension was released and the weight came down. Why do we need these weights? Well, these weights are to keep tension on the line steady. Because the line will expand in summer heat and contract in winter cold, it will get longer and shorter and would sag. in the summer and perhaps snap in the winter. So what happens is that they keep these weights in order to keep tension on the line. We have a pulley system here. The weights are pulled down to keep the line tension, but they're on the ground because the tension's been lost because of the breakage further on. Okay, I'm going to take a quick view of exactly the same pole from the other side. Right now we're facing eastbound, okay, towards Lee Station. This is just the same pole. I'm looking backwards a little bit just so that you can get a view of this. You can see the more clearly now the pulley system here, which is allowing these lines to set off. We're going to have one for the east and one for the west, by the way, right? New lines setting off. The lines that we see that are not connected to the pulleys are the normal lines powering the system. So I'm just going to verify that I'm properly recording this. Yes, I'm recording. Good. All right, let's continue then. The lines that you see that are not on the pulley system actually start at the tunnel. At the tunnel they start, and we'll see them ending a little while later. The new lines start here, but they don't actually start providing power to the train until a few poles down. So let's move on down. One pole further down towards the Lee Station, we see the train again, and now we see a much more sophisticated setup. Again, we see more of this this tensioning here, with more weighting, okay, because we have to weight the poles in both directions, and they have to be weighted going back the other way as well, okay. And we're beginning to see here the crossover between one set of lines and the other. You'll notice they cross from left to right, and you'll also notice on the right that the eastbound side is sagging, right? So the westbound line is still in good condition. It's probably a little bit out of registration because of the damage, but probably not too bad a shape. Needs to be verified. But the right-hand side is clearly sagging there, all right? And we can see the same pole from the other direction, okay? Exactly the same pole we just saw in the other direction. We can see the weighting again. We can see the pulleys. We can see some of the sagging. Let's move on one step further. Okay, we've gone down, we're again facing eastbound. Now you also see the breakage, right? So this pole, you can clearly see this dropper, which is you can see a dropper over here that is clearly not connected to any line anymore. This is a voltage connector that connects the two lines together. It's not connected to a line anymore. So we don't have any weighting here, but what we do have clearly is crossing over of lines where the one set of power lines connects to another, and eventually we'll get back to the normal lines as we go further down. This is a view of what we just saw facing, again, westbound, just so that you can get a different perspective on it. Continuing on down. Notice, by the way, the broken pantograph of the train here on the far right of the image. Another pole, more of these hanging risers here that are broken, and now we see the weighting of the line that was good above. This is the end of that line. This is where the tension of that line that is going towards the tunnel is where that is kept in tension. Tensioning we saw before was the tensioning of the line that's going out towards Herdman. So this is the tensioning going back the other direction. And again, here is a view of the pole we just saw facing the other way. You can see more clearly the broken pantograph again. It's really badly damaged, that pantograph. They're going to have to clearly replace that. I'm slightly surprised they didn't remove the train, but they seem to be now starting to work around the train being there. And then this is going downhill one step further. We see here, leaving this pole, we're facing up towards Ottawa for the final time. Notice that they've set up this grounding as they prepare to repair the lines, because they want to make sure that if anybody accidentally applies power it's not going to electrocute the workers working on the lines. So they've connected the lines to the rails for good grounding. So going, we can see this line here has no lower cable. It's disappeared. It's gone. Bits of it are lying on the ground. In fact, down below. On the right-hand side, you see the normal westbound cable, again, in good condition. And you can see this weighting system in good condition. Okay, this weighting system is essentially tensioning the westbound cable going up and the eastbound cable going up. And it hasn't come down to the ground at this point. We'll stop there. I am going to post this in a few minutes.